Here is a demo of wildcat classifier web application running on my iPhone. So this app basically takes in images and input of a wildcat and classifies into specific category. Let's start with the built-in images first. So I have a couple of images in the app. So I'm going to select the first image, which is of the type Jaguar. Then I will try to select the second image, which is of the type lion. We could also try to upload the image from my camera, which is I'm going to do next. So I'm selecting photo library, then selecting this image. This is the image of a puma cat. When I click submit, it classifies this as an puma with 100% probability. Let's try one more. Then I'm uploading an image of another wildcat, which is of the type Jaguar. And let's see how it classifies as. It classifies as a Jaguar 100% probability. So this is how the demo works. You can learn more about the code by following the link in the video. Thanks, bye. All right, time to look at the code. So I have started a Google Colab notebook where we are going to write most of the code. The first thing that we need to ensure is you have set up GPU as your runtime. So I'm going to click runtime, change runtime type, make sure the GPU is selected. Then the second thing I'm going to do is my image data set, I have uploaded it to Google Drive. So I first need to mount the Google Drive so that I can access this data set as if I'm using it as a local file. So I'm going to mount the Google Drive. It's going to ask me some permission, and since I'm granted permission, it is not asking for it anymore, but I can start using it now. Okay. Then I could unzip the file locally if I want to, but I don't want to do that because I will be using a dataset library that can directly take a compressed TGZ file as an input. So let me install some of the packages like transformers, datasets that I'll be using in this particular example. Also model evaluation. In the Gradio UI I'll be using for creating UI library, and Hugging Face is also used for creating a UI library. Transformer is where I'll be using Vision Transformer package to fine tune our model. Dataset is the library where I can generate a data set from the images and pre-process it before feeding it to the machine learning framework. So let's run this code. This will install some packages on our environment. Then let's load our dataset. So since I have mounted the Google Drive, I have already copied the Google Drive file over here, and then I'm going to download it, and then I'm going to update my image dataset with those particular images. So there are about 2,389 images. This dataset has the dictionary of dictionaries. It has a train dictionary. Inside that again we have two more dictionary, one containing images, the other containing the labels. Okay, so let's look at how the train dictionary looks like. So it has two features, labels and images. Let's look at the first row. It has an image and it has a label of 0. Let's try to display those images and associated labels, at least the first 10 images. So as you can see, it is displaying the images of a few categories like Jaguar in the first few images. Okay, let's look at a few other images also. Maybe we can start with 300 range. Let's see what kind of images come up. So as you can see, this is kind of a puma, kind of a wildcat. Let's try one more. So as you can see, this is a different type of wildcats, right? So as you could see, there are wide variety of wildcats in our training dataset that we would like us to classify. As you can see, the label also keeps varying as the category type of images changes. And this label is at this point an ID, but we will also see what is corresponding label for that. So these are the labels that we printed out earlier. We have African leopard, caracal, cheetah. So this is number 3. So 0, 1, 2, 3. So this is a clouded leopard because it has a cloud like spots on his body. Okay, so now let's time to split our, currently we just have a trained data set in our data set, right? So here you saw it wasn't a trained data set. So we also need to create a validation data set and a test data set. Now these two, like we will split as 80% train, 10% validation and 10% test data set. And the validation and test data set will not be used in the training. They will be just used for evaluating the accuracy of the model. So first, let's create a 10% of validation set by using this code. And we will copy that. We will rename this test as validation. And as you can see, now it has two data sets. One is train and the other one is validation. And it has validation has 239 images and test has about 2150 images. Let's update our original data set with those two sets now. So original data set has now train and validation. We need to create one more data set called test. We will repeat the same method. We will split the train data set into 90% train and 10% test. Okay, so this is the test data set, and this is the overall data set that it looks like. So overall, if you take a look at the data set, it has 80% images into train data set, 10% into validation and 10% into test. Okay, now let's look at pre-trained model and why it is not enough just to classify our wildcat images as well. So we are going to load a pre-trained model, which is the vision transformer based version, which uses 16:16 patch, and it's available at Hugging Face at this checkpoint. And we are also going to use a GPU, which we saw earlier using CUDA library, GPU available, and then we need to convert model into the GPU. And then we also need to convert data into GPU, that we'll do later on. But let's first convert model into GPU, and we'll also set up model for evaluation so that we can measure how good the model is. Okay, so this basically it prints out a verbose information about the vocabulary inside the model, then all the basic configuration of the model, the different layers of the model. And device code will print out if we have a GPU available. So we have a CUDA, that means GPU is available. Then we also need to extract a feature extractor from the model, which will tell us how to pre-process the image. So there is a very convenient method available from our model, like for the vision transformer model, what kind of feature extraction is required. This gives you a reference to that. And this will tell you that this is the kind of feature extraction that is required. We need to resize the images to 224 by 224. Then we need to normalize the images. Then we also need to adjust the mean and the standard deviation of the image so that they appear, so that they are coming from the same distribution. Right. So let's take an example look of one of the images. It's the Puma type of the images. We are going to extract the features from the images using this feature extractor and convert into PyTorch tensor array. So this is how the image would look like. And let's submit the image input, that pre-processed image, to the model, and let's look at how the output of the model looks like. So these are the logic score output, which are just generally a score range, which does not have any upper limit. So we need to convert two probabilities into 0 to 1 range by calling argmax functions of the model. Then this will give you a model with 287 classes, and this is going to give a category, though not 287 classes, this is just the ID. So vision transformer by default, it has about 1000 classes, okay, and it gives the ID of the image that associate is as ID of 287. Let's look at the corresponding label for it by using the id2 label function from the model, and it categorizes as a lynx catamount, right? So lynx catamount, and this is actually image of a puma. There's a difference between that. The puma usually appears to be a bigger cat than compared to the lynx, and there are a few more differences. So as you can see, our pre-trained model is able to only classify only a broad level category but not a special categories, but we need to classify this into a more specialized category like puma, and that's the reason why we want to fine-tune the model, right? So let's look at the fine-tuned model. So we will load again this model as the pre-trained model. We also need to prepare the labels, because you saw the original model has about 1000 labels, but we have only 10 labels. And we also need to create ID to label and label to ID, which basically maps the labels to integer and integer to labels. Basically, we need to prepare those two IDs, reverse mapping and forward mapping, and then we create a reference to this pre-trained model with this new kind of labels we need, and the ID to label and label to ID mapping category, right? Let's prepare the model for that. So we saw that we need to pre-process the images for our model, right? So let's prepare for pre-processing of the images, like we want to normalize, compose, random resizing, all the operations that we could do by using this. We could also normalize the images that we need to do, and this is what is the feature extractor size, 224 by 224 images creates. And we will use a different transformer for train versus validation. For train transformer, we want to make our model more robust, so we will randomly resize the file, resize the image. We'll also create vertical and horizontal flip of the model, so that we create variety of images from the same input data set and feed to the model with the same label, so that model can become more robust. For validation, our focus is on the accuracy metric, and we don't want to resize any. We don't want to do too many transformation, so we just want to do resize and center crop and normalization. Okay, and these are basically two functions that we use: one for transforming train dataset, and the other one transforming for validation dataset using these transformations. So let's create this transform this dataset by using the actual functions, and put this into train, validation, and test dataset. So we will use a train transform for only train dataset, and we will keep validation transformation for test and validation datasets. So this is how the transform dataset would look like. Here is a sample image from our original dataset. The same image, if you look at after running through pre-processing layer, so as you can see, the image looks different because it is doing a random resizing, flop, and random flopping, flip flopping. So if you run it again, the train dataset again, every time we would run it, it would show me a random resizing and random crop, right? And this is required for generating lots of random input images, but from the same image dataset, so that our model become more robust at identifying the images. And for the validation image dataset, even if you run multiple times, it should just keep the transformation same. We are not randomizing the images for validation and test datasets. Okay. Another thing that you need to remember is the dimensions of the images that we feed to the model. So let's look at the images that you have. It has a pixel value and it has a tensor of certain size, right? So let's look at more shape of these images. It has basically each image, it's an array, and each image is basically 3 by 224 by 224. 3 is the number of channels, which is like an RGB channels, and 224 is height and width of that image. Okay. Now, but what the vision transformer expects is the number. It has array of images it expects, where the first dimension is the number of images followed by the number of channels followed by width and height. So we need to create an array. So one method to create an array is just a simple for loop. Let's see how it looks like once we do that. So here the dimensions of the images is not right. This is not what we want. Let's see by using torch.tensor if we get right. Again, we don't get the image of the right size because the first dimension need to be 4, which is the number of images. So instead of using a simple array, we use a stack functionality of torch, which would create the images in the dimensions that we want. So once we run the stack, we see that we are getting the first dimension as the number of images. Like in this particular case, we are just sampling 4 images. Then the number of channels, number of height and width. So this is the format in which we need to feed these tensors to our model. Okay? So we're creating a simple functions called collate functions, where we are going to transform the dimensions of the images so that we can feed it to the model, and we will run it. We can create the data loaders if we need to feed the model in a batch. All right, so okay, so this is how we set up the model for the training. We have returned the find model. We set the batch size, what matrix we need to measure, then what is the model, base model that we are downloading. So we are going to follow the evaluation strategy called steps, or we could follow the epochs. What is the learning rate we want to set? You can play with this value. The batch size we want to set, number of epochs. We want to load the base model at the end with highest accuracy, and where the directory need to be logged. And we also want to push to the Hugging Face hub. Now in order to push to the Hugging Face hub, we need to have ability to write to the Hugging Face hub. So we run this code. It will actually prompt us for Hugging Face token. Now for the Hugging Face, you need to create a write token for that. So let me show you how you do that. So Hugging Face, if you need to first create an account in the Hugging Face and then log in, and then if you go to the settings and then access tokens, you can grab your Hugging Face tokens from here, and then you can submit it here, and then it didn't work. Let me try again. To copy it. Paste it. Okay, so token is valid, and this is the method that you run it so that you can upload it to the Hugging Face hub. Okay, then this is a sample method I have written, but I will not use this. I will use a different code for training. Then we also need to set up for a model for evaluation, what metrics you want to measure. Here in this particular case, I want to measure the accuracy. So I'm writing a simple function how it can calculate the accuracy, and I will pass this function to my trainer function. So let's create this compute matrix function. Then now actually I'm setting up it for real training, where what I'm changing is I want to run for 5 epochs, which is basically going through the training set as it 5 times, and I'm also passing the compute matrix function. Okay, this is I'm preparing it for training the model. Then I'm going to actually run the model here. Now this is the time where it started the fine-tuning the model. So it's training on our training data set, and it's running for 305 steps. So once it is done, then we will get the results. and then we will evaluate on train, validation, and test data sets, how well the model performs. Okay, it's gone through at least 50% of the data set, and it has gone through half of the epochs. Okay, the training is done. It has trained the model, saved the model. It has also uploaded the model to Hugging Face, where you can see it over here. So if I go to the models, and if I type in my alias, so you can see wildcats. This is the image model that it has been updated. Okay, it's uploading the model. It hasn't uploaded, but here it where it will appear. It is still uploading the model. Here it is still showing the last version of the model. It was uploaded 10 hours ago. But let's say if it gets refreshed once the upload is complete here. Okay. Alright, so it looks like it is done. Let's take a look at it. If it's reflecting here. So here, as you can see, it's updated 1 minute ago, and this is the model, which is all the details you can have. Alright, so model is available. Now let's look at the inference. So let's load a test image, and I'm going to download this model which I just uploaded on the Hugging Face. Then I have a simple method to classify the image. So it's going to take this test image as an input. It's going to run this on a GPU, the model. Then we are going to get a reference to the model. We are extracting the features from this image, and then converting to PyTorch tensors, and then also coding to CUDA using this two device. Then we are going to passing to the model this input image with the feature extracted. We are going to get the logic output from the image from the model. Then we are going to convert into probability using the torch.argmax function, and then we are going to get the label by calling this. So let's see what the model returns. So in this particular case, the model is returning, let's see, it's downloading the model first. For the first time it's doing the model. Once it is downloaded, it will not download again. So it is classifying as the jaguar. Probably we can try with one more image. Let's see, this is the tiger, and let's see what happens if we load this tiger here. Yeah, so it's predicting correctly. Okay. Now, so this is all about how we can do inference with the model. Now we also want to create a Gradio, which is a web UI. Let's say if you want to share this model to someone, and if you want to run this model, how can you do it, right? So you can create a Gradio model for that, and this is a simple code for this. I'm just showing the code here, but I will also show you how can you run this Hugging Face model. So the code is very simple. Gradio is basically a library where you can create a simple UI. So first of all, it needs a method to classify the image, which is exactly same that we saw earlier. Then in order to create a UI, we call the gradient.interface function, right? Where you can pass a function to classify this image. This is same as a classify image function. Then we can say that what is the type of inputs you need. We need the ability to upload an image and classify it. So it will create an image as an input, which will allow user to upload that image. It will also do an examples you can of the image that you can upload and keep it there if the user doesn't have images handy. And outputs, what do you want to image the output, and you can use launch function to create the output and show it to the user. And I will actually create directly on the Python on the Hugging Face itself and show you how can you do it. So first of all, you need to go to the something called spaces, right? And you create a new space and call this as, let's say, wildcats. Use any license open rail. Other option, you can use Gradio as a Gradio application, and the other you can keep as a default, and the create space. Once you create space, it will appear something like this. I'm telling you my existing space, which is this one, okay? And we need to create bunch of files in this. Basically, this is nothing but this is how it is nothing but a get repo, okay? So first of all, you need to create some files, right? So let me walk you through the files. The first, you need to create an app.py file which has your main code. Then the JPG files, which are the examples of some cat images that you can upload from your local repository. A requirement.txt file which contains actually all the packages that you need, okay? So you can just create. What you can do is you can if you initially when you create the space, it will be empty. So you can create a new file, name it as requirement.txt, and just upload the Python package, type the Python packages and save it, okay? Then you also similarly you create the app.py file by using the same function, create a new file. Then this app.file, this is the code. You import the Python packages, you type the model ID which is required, you type the labels which are for your model, and we have added this classify image function and this same image same gradient interface function where we'll say what method you want to use to classify the image, what inputs you need, where you can upload the image, an image type input, some examples of the existing image if the user wants to use them, and what is the output that you want to show, okay? So this is the simple code. Once you add this code and once you add all these files, and you can also upload these other files that I've showed you, this is a simple JPEG file that you can just upload from your local folder by saying add file and upload file, okay? Once you add up this file, this running will actually show you build, and it will also show you the log. Then once the build is complete, it will show you the running mode, and once it is running mode, that means your app is ready to use. So in order to use that, what you do is go back to the wildcats, and you can flip between the two. If you go to the app, this is the app which is ready to run, right? So this is an image input that we have created. You can either select these two cat images that we have uploaded, and it will show me it has been classified as jaguar. If I select another image, it classifies as a lion. I could also clear this, and I could also upload it from my local folder. Okay, so let me see if I have something from my local folder. Okay, let me try one from the tiger. I'm going to upload this and click submit, and this will show you what is classified as. So it is classified as tiger with 100% probability. So this URL is public URL, anybody can use it. So this is how you can create your app and share it with everyone for use.